Life cycle costing, seeing beyond the purchase price. Why LCC matters. When we buy an asset, say a pump, vehicle, or piece of infrastructure, our first instinct is to look at the price tag. But the purchase price is only a fraction of the story. Life cycle costing, or LCC, looks deeper. It helps us see the total cost of owning, operating, maintaining, and eventually replacing an asset over its entire life. The goal is simple: make smarter investment decisions that reflects the real cost, not just the cheapest upfront option. After all, what seems affordable today can become expensive tomorrow when we factor in maintenance, energy, and replacement. Main components of LCC. An effective LCC analysis includes several key cost elements: capital cost or CapEx, purchase, installation, and engineering; operational and maintenance cost or OpEx, annual servicing, spare parts, inspections; energy cost, recurring yearly expenses; rehabilitation or replacement costs, major renewal during the analysis period; residual or salvage value, the asset's remaining value at the end of life; discounting, bringing all future costs back to their present value using a discount rate. The simplest formula for calculating the net present value or NPV of the total cost is as follows, where C0 is the initial cost, CT is the cost in the year T, Sn is the salvage value at the end of year N, and R is the discount rate. Steps to perform an LCC analysis. Define the analysis horizon, for example, 15 or 20 years. Collect data, initial costs, yearly O&M and energy expenses, equipment life, major repair or replacement cost, discount rate and residual value. Model annual cash flows over the defined horizon. Discount all future costs to their present value. Compare alternatives and perform sensitivity analysis to understand how results change if the key assumptions shift. A practical example. Imagine an organization deciding between two pump options. Both serve the same function, but their costs differ. Let's compare them over a 20 years horizon and consider the following assumptions for the two pump stations. Pump A is cheaper upfront, but pump B is higher initial cost but more efficient. The numbers tell the story. For pump station A and B, consider PV of annual cost, PV of replacement at year 12, PV of salvage value, and initial cost. As you see, pump B emerges as the better option, around 27K cheaper in today's value over the 20-year period. Why the costlier pump wins? Three main factors explain the difference. It consumes less energy, saving about 6,000 kilowatts per year or $1,200 annually. It doesn't need a costly mid-life replacement like pump A. It retains a high residual value after 20 years. This clearly demonstrates the cheapest upfront option isn't always the most economical in the long term. Sensitivity analysis. What could change the outcome? LCC results are sensitive to discount rate. Higher rates reduce the importance of future costs. Energy price. Rising energy price increase the advantage of energy efficient assets. Actual service life. If pump A lasts longer or pump B fails early, result may shift. Replacement cost assumptions. Future cost changes directly affect PV results. Always test how your decision holds up when key parameters vary. That's good practice in infrastructure investment planning. Key takeaways for reporting in SAMP or capital decisions. Choose a realistic analysis horizon and justify it. Document all assumptions transparently. Include sensitivity and risk analysis in your report. Link financial outcomes with performance and regulatory implications. LCC is not just a financial exercise, it's a lens for holistic, long-term asset management. In summary, across multiple energy and discount rate scenarios, Pump B consistently remains a better long-term investment. For instance, at 5% discount rate and $0.2 per kilowatt hours, differences roughly equal $27K. At 3% discount rate, differences roughly equals $39K because future costs way more. At $0.3 per kilowatt hours energy price, Pump B's advantages widens further. Even under low energy prices, Pump B still outperforms, making the decision robust. The lesson from these assumptions and calculations results in when choosing between two asset options, think life cycle, not a sticker price. LCC transforms how we see value, helping organizations invest wisely, manage risk, and ensure long-term financial sustainability.